Okay, so now we have built inference pipeline, we have saved all the model object. Now we will deploy this particular model into Gradio deployment. So Gradio is basically a option where you can deploy your machine learning model without creating a proper UI, because Gradio will give you the UI automatically. You just need to mention what are your inputs and output. Then Gradio can help you to deploy your model for a temporary time. So we will deploy the entire machine learning model on Gradio UI. Okay. There are other options also like Streamlit, Flask, using API. But first we will focus on the Gradio part, and in the next session we will see how to create an API, and we will also see how to deploy the model using Streamlit application. So whenever you want to deploy any machine learning model or any kind of deep learning model, you can refer Gradio or Streamlit. These are the two frameworks which mostly used in the industry for a okay. So first thing you need to do is, currently we are running the entire Jupyter notebook inside this environment, disorder prediction environment. So you need to import this Gradio library inside your Anaconda environment. For that you can just go to CMD terminal and type this command, pip install Gradio. I have already installed it like this way. So you need to activate your Conda environment using Conda activate disorder prediction. Then once the environment is activated, you can just simply type pip install Gradio command, so that it will install all the libraries for this Gradio deployment. Once that is done, then you can import this Gradio as GR. GR is basically an alias name. So you can import all the packages which is required for this Gradio deployment. Second, you need to load the model as well. So again, joblib.load, it will load the rfc model.pickle file that we have saved in as a binary file in our machine. So this is the train model, and this one is the scalar model which is fitted on the training data. So this is the reason we need to save, because whenever we deploy the model, we don't need to retrain the model again and again. So first load the model and scalar object, and then I've just copied the return prediction function in this part, because we are going to use same return prediction function in all the deployment cases, like whether it is Gradio, Streamlit or Flask or anything. So return prediction function will take the model parameter, scalar parameter and data parameter. Then it will do all the pre-processing, converting the data into list of values, then converting into a number in array format, then scaling the data, and then prediction. And once you have the prediction, you can return the label of that particular input. And this return prediction is basically used as an inference pipeline. But there is one more function we need to create, which is predict UI. So this particular function is mostly used for Gradio UI, because as of now we have not saved the encoding logic, because we have done the encoding. In few cases we have used label encoder, but if you want to save that, you can save that as well. But as of now we will not save the label encoder, we will do that process manually. So this predict UI will take all the input parameter, like whatever the independent variable we have in the data, it will take all the input parameter like gender, age, occupation. And on the user interface, let's say if I select male, then in the backend it will convert that male value to 1. And if a user select female, then in the backend again it will convert that female value to 0. So all these rules are hard coded inside this predict UI function. But if you want to skip this particular part, then you can use label encoder. Okay, but as of now I just wanted to show you how label encoder works, and without using label encoder, how you can convert your raw input data into a numeric format. So first thing, once you get the gender, we will check whether it is male or female. Then based on that we will get gender code 0 or 1, because we cannot directly pass the text data to the model. Then occupation. So we have n number of occupation: accountant, doctor, engineer, lawyer and all. Then let's say if a user pass occupation, like occupation options, and if it is present in that particular list, then it will return the occupation code. So if you see accountant, doctor, I have kept it in a ascending order, because label encoder by default uses ascending order. So if the category is in A, B, C, then it will assign 0, 1, 2, 3. And if it is in X, Y, Z, then the last number will be assigned. So first, if a user pass occupation, let's say lawyer, manager or anything, then in the backend we will identify the index location for that particular option, and that will be your occupation code. Same for BMI option. And then once you have all the categorical values to be encoded into numeric format, then again we will create a data dictionary. So gender will be gender code, age, occupation code, but rest of the things are already numerical, like sleep duration. So for that we don't need to convert any values to numerical value, because indirectly, like directly, we are getting input value in numeric format. So only for categorical variables you need to create this logic. Once you have the data variable ready, then we will call the return prediction function, and here we will pass model, as model will be the input parameter, scalar object and data object. And this entire return prediction function will return the final value, whether the person has sleep disorder like insomnia, sleep apnea, or no disorder, which is none. So this is the function predict user interface. So whatever data we will pass on user interface, it will convert that particular data into numeric format, and that data will goes to the inference pipeline, and then we will get the final output. Now once this part is done, then we will create a user interface. So the good thing about Gradio is you don't need to know HTML, CSS, JavaScript and all to create a UI. You can just mention your input type and Gradio will give you a dynamic UI. So you can use that. So for most of the machine learning, deep learning project in data science, creating a user interface is a very hectic task. But as a data scientist or machine learning engineer, you don't have to worry about creating a UI. You can just use Gradio for temporary deployment and it will give you the entire UI. So we will going to use that only. So using Gradio library, I have mentioned that the first input is radio input, and inside the radio input I have created two choices, female and male. Then label as gender, female for 0, male for 1. But here we are using radio button, so don't need to mention 0 or 1, because in the backend on this function we have take care of that. So we will directly convert male into 1, female into 0. But just for simplicity, I am mentioning that particular part. So using Gradio.radio button, you can get two radio button, one for female, one for male, and then user can select according to that. Then for occupation also, I have created multiple radio button, like these are the, so each radio button will be represent for each occupation. Then radio button for this category also, like normal, normal weight, obese, overweight, and then BMI category. And then slider. Slider is basically to enter the numerical value. So let's say sleep duration input. So sleep duration is in 1 to 10 format, like 1, 2, 3, 4, 5, 6, 7, 8, 9, like number as hours. So in slider, you can set the minimum value 5 and maximum value 10. So using this case, you can limit the input so that user will not enter any outlier value or any other random value. So this is how you can like rectify if the user enters any wrong value, you can rectify that thing. And then value will be, default value will be 7, step will be 1. So user can increase 1, 2, 3, 4, 5, 6, and this is sleep duration. So all these sliders are created for numerical input. So let's say you have 13 or 10 variable, create slider, then radio button, input text box, and based on that you can take the input from the user. So this is similar process that we have done in ask user function. So in ask user, I was just taking input for all the variable, but in radio we have dedicated input object like slider button, radio button. So that is the main logic. Once you create all the input object, then we have to create a interface. So interface is nothing but a final UI, user interface, where user will enter the details and we will get the output. So we can create a Gradio interface function. inside this Gradio interface function, we need to pass only one function. So this function is nothing but the predict UI, and the inference pipeline that we have created, which will go inside this predict UI function. So we don't have to mention that here. And then in the input path, you need to mention all your input sample, like what will be gender input and all, like whatever the objects that we have created using slider and radio button, that we will pass inside the input list. And then the output variable will be Gradio.textbox, because our output is in text format like none, sleep disorder and sleep apnea. So to display the output, we can create a Gradio.textbox, and label will be predicted the sleep disorder, and title for the entire project is sleep disorder prediction, and then a small description. So this is the Gradio interface. Once the Gradio interface is declared inside this demo variable, then you can just launch your entire application. So we have to write demo.launch, and share equal to true will return a link, a dedicated web URL that you can use across the internet. Because let's say if I don't pass share equal to true, then I will get a local deployment link. So only I can access that particular project. But if you mention share equal to true, so Gradio will deploy your entire application on Gradio server, but that will be just for the temporary time, not for the permanent phase. So we will get the web URL that you can share with any other people, and those people can access your entire application via internet. Debug equal to true means, let's say while running the code, if you face any issue or any error, then debug equal to true will, because of this setting, it will print where the error is present. So it will be very easy if you want to debug your code. Okay, now once this is done, you just need to execute the code. And okay, I'm getting one blocks debug. Okay, D is capital. Let's launch the code. Okay, now you can see this 127.0.0.1.786 is the local deployment link. So if I use this link only, I can access the entire project. But as of now, I'm sharing this particular parameter, share equal to true. It will return the public URL. So this entire project is running on local URL as well as public URL. So this public URL you can share with other people. So let's say if I click on this public URL, in the new window, you can see an entire web application is running with proper UI. So we need to wait for just 2-3 seconds so that it will get loads. Here it is. Here you can see the entire UI on notebook also. And let's see the URL on the web application. Okay, it is loading this URL. Now see, this is the entire web application, and it is currently deployed on the Gradio server. So you can see the link. So if you go to this particular address, you can also view this particular UI. But as soon as I close this Jupyter notebook, you won't able to access this website. But for temporary phase, when I'm running the server, you can access this website. Now how to use this? So our problem statement is sleep disorder prediction. So here first a user need to enter the data, like whether if user is male or female. So let's say I'm male, then using slider button you can select the age value, and you can also enter that using this particular button. Like you can enter manually, or you can just slide the slider up, according to the age value. So let's keep age value little bit high, 65. Let's select occupation as nurse, because we have seen that occupation, quality, body mass index, then age, these are very important factor while predicting the sleep disorder. So let's nurse. Sleep duration is very low, let's say somewhere around 5.1. Quality of sleep is also very low, and physical activity level is very high. Stress level is also very high. BMI category is obese, and heart rate is very high. Daily steps very low. Systolic blood pressure, let's increase this, and same for diastolic pressure. So as per assumption, these are the parameter. If a person have, then that person will definitely face sleep disorder. Okay. Now let's check what model is predicting on this data. So if I click on submit button, here you will get the prediction value, and the model has predicted that this particular person has sleep apnea. So let's change some parameter. Now let's select software engineer. Quality of sleep is very high, physical activity is very high, sleep duration is very high, and blood pressure is little low. So let's select this value and let's predict on this data. Now this person does not have any sleep disorder. So this is how model is predicting. So what we are doing right now is we are selecting some values using front end. This front end has been created by Gradio library. We just need to select the slider and radio button to match the value that we want to pass to the model. Then Gradio UI will convert that particular raw values into numerical format, and then it will pass to the inference pipeline function, and inference pipeline will return the prediction value. Then same Gradio UI will take that value and it will display inside this text box. So this is the end-to-end project. Now we started directly on the Jupyter notebook while reading starting with the data reading, that pre-processing, ED and all. But now we have deployed the entire entire project on Gradio live URL. So till now this Jupyter notebook is running. Anyone can access this particular website. So in the next step, what we will do, we will try to build the similar kind of web application using Streamlit library. So Gradio is one option. You can go for Streamlit as well. But for Streamlit, we cannot use Jupyter notebook. So we will move on to the PyCharm part, and in PyCharm we will create a Streamlit web application for the same project. And after that, we can also create an API for this web application, because API does not have any user interface. So how to create API, how to pass the data to the model using Postman, we will see that part also in the next session.